Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM trial paper, year 2022, and this is for Kedah paper 1. Okay, let's begin with question number 1. So in this question, this is from the chapter function. We're supposed to, the first part, you're supposed to determine whether function fx and gx, whether fx and gx, they are actually a function and gives justification. So you can see from the diagram here, the first graph for fx is a curve this way, right? And gx is a curve in this direction. So the main thing is to determine whether it's a function or not, we use what we call a vertical line test. Now, a vertical line test works like this. So when I draw a vertical line, let's say we start with fx, okay? We draw a line, you notice that it actually cut the vertical line actually cut the function, the graph or function at one point. So when it cut at one point, that means there is one x value that map onto one y value, right? Now you may have multiple x value that map onto the same y value if you draw a horizontal line, but that's not the main thing. What we want to know whether every object has only one image. Remember, definition of function. Function is a relation for which every object has exactly one image, or every x value has only one y value. So to determine this, right, maybe we can, I'm going to do my solution over here. I'm going to write it over here. Okay, we say that for part A here. So using vertical line test, right? We draw a vertical line. Now we notice that the vertical line cuts the graph y equals to fx at one point. So meaning we can put the user word, the symbol, therefore every x value has exactly one y value. So we can confirm that fx is a function. Now you can also say it's a many-to-one relation. We know many-to-one and one-to-one, they are function. Yeah. The rest, one-to-many and many-to-many, they are not function. So we can also explain from that point of view. But here, I think we can maybe just say using vertical line, right? Vertical line test, draw a vertical line, show that it cut at one point. So we say that every x value has exactly one y value. So it's a function. Now for the second one, I'm going to draw vertical line like this. You can see for gx, right? For y equals to gx, right? The vertical line cuts the graph at 2 points. Yeah. So in this case, you can say we have what do you call that? We have two x value. One x value have two y value. Okay. Or should I say x value has two y values. So we know it's not one-to-one. Okay. So we say gx is not a function. To be exact, it's a many-to-one relation. A multiple x map onto the one-to-many relation. One x map onto multiple y. So it's actually a one-to-many. So it's not a function. Okay. So I know my explanation a bit long here. Yeah, we can actually cut short. Yeah, by saying that, yeah, every, like for example, the first one can say is many-to-one relation, is a function. Second one can say is one-to-many relation, so it's not a function. Okay, let's move on to B. Gx is given as 3x plus 3, and you're supposed to find the value of m given ff inverse of 3m squared plus 2 equals to g of bracket m plus 3. Now, actually, this there's a shortcut to ff inverse x. I hope you know about this. So when we Pick a function. Let's say f, you inverse it. Let's say you end up at y. Then you follow on by going through function f again, you end up at x. So when you say f inverse x, you're actually going backwards, then you go forward, and you end up at the same place where you started, right? So when you see this, we know we can cancel each other off, and we write this as 3m squared plus 2, and this is equals to g. We know our function g over here is, this one, 3x plus 3. So we put a 3 bracket square plus 3. Now, what do you put in the bracket here? There is a m plus 3. So what we need to do is expand this bracket, m squared plus 6m plus 9, and then you plus 3. Again, let's expand this, 3m squared plus 18m plus 27 plus 3. Now, on your left-hand side, you can see this is 3m squared plus 2, which we can cancel, right? I can cancel this and this. Let me simplify. This is 2. This is 18m plus 30. When you bring it over, 18m is now negative 28. M is 28 can divide by 18 is 14 over 9. Not a nice answer, but yeah, this is the answer, right? Okay, question number 2, this is from the chapter quadratic functions. You're supposed to change the quadratic function from, we call this a factor form, into what we call a vertex form, and then state the value of m and n, then sketch a graph. Okay, so let's start off with bx equals to this. Can we expand this? This will be x squared minus 3x minus 4. Okay, I prefer to expand this and not expand the bracket 2, because when you want to complete the square, remember your coefficient of x squared has to be 1. So we just expand the double bracket here first, keep the 2 outside, and from here we can complete the square. Remember, the way in which I'll complete the square is a bit different. In school, what you learn is that you probably just take minus 3x, take half of 3 over 3x, negative 3, you divide by 2, you square it, you minus it off, okay? So, yep, most people, most teachers will teach you this method. You can do that, okay? But for me, I will skip this because I find that a lot of students will tend to mess up the more steps you write, right? They tend to change a negative, they think it's a positive, yeah, when you're supposed to square the bracket first. So what I'll do is, for me, if you have what we call a function in this form, right, general form, when I want to complete the square, I'll take half of h. We write this as h over 2, we square it, and then we immediately minus this off. Yeah, it is a lot easier. Okay, why? Okay, let me just give numbers. It's easier to understand with numbers. Like, for example, this is negative 3, right? Half of it, negative 3 over 2. Then you square it. Then immediately we take negative 3 over 2, we square it. So you get 9 over 4. Keep the minus 4. Now, the reason why we minus this is that when you expand this, you get x squared. This is like a plus b squared, which is a squared, 2ab, and a b squared. So when you expand, you get x squared minus 2 times x times minus 3 over 2 is negative 3x. And then when you square this, you get 9 over 4. Now, notice you have an additional term of 9 over 4 here that you have to minus the 9 over 4 off, so that you get back the same thing as what we have here, right? But of course, you don't do that. You keep the bracket because we want to write in this vertex form. We want to write in this vertex form, okay? So let us just simplify this. This will be 2 bracket x minus 3 over 2 square. This is 4 times 4, 16. 16 plus 9, 25. Over 4, close the bracket. Now, these two you can multiply in, you get x minus 3 over 2 square minus 25 over 2. Now, I hope you understand why 25 over 2, because we are multiplying inside here 1 by 1. So this is 25 over 4, cancel with 2, 25 over 2. So there you go. This is your equation in vertex form. Now, the next thing is we need to state the value of m and n. Now, by comparison, we can write this down, 2x minus m squared plus n. m is 3 over 2, n is negative 25 over 2. Okay. So I'm done with my completing the square part. So next, to sketch the graph, maybe I draw the graph on the right-hand side here. We know based on this equation here, your px has a minimum. I know it's a minimum because my a coefficient of x squared is 2. This is positive 2. It's more than 0. So if it's more than 0, the minimum value is negative 25 over 2. When the one inside the bracket is 0, x is 3 over 2. So we can see that this curve has a minimum. Maybe I will draw a curve first, right? Then I will draw the axis like this, like this. We can adjust it later on. This is your 3 over 2. This is your negative 25 over 2. Notice it does cut the x-axis at 2 points here, right? It may cut the y-axis as well. It does cut the y-axis. We define the y-intercept as well. Now, for x-intercept, don't bother working too hard because we already have this general, what do you call that, the factor form, right? We know at x-axis, your y is 0. Your 2x minus 4, x plus 1 is now 0. The roots are 4 and minus 1. That means this is minus 1 and this is now 4. Okay, we just have to find a y-intercept. Y-axis, x is 0. Here we can sub inside any you want. You can use back this factor form, or you want to use your vertex form here. This is your vertex form, up to you. Maybe I use the factor form. I know I put 0 inside your y, or your p. Px is the same as your y. I put 0 inside here too. 0 minus 4, 0 plus 1. This is negative 8, right? So I know my y-intercept is at negative 8, and my graph is done. Okay. Okay, question number 3, we are supposed to solve this simultaneous equation. This is under the chapter system equation. So we either make x or y subject. We have a linear and a non-linear. But for me, when I look at this, right, my linear here, I can make x a subject, I can make y. But my non-linear, I can see that x appeared once, y appeared twice. So if I make x a subject, I only substitute one time. If I make y as a subject, I have to substitute 2 times. All right. So let's make x as a subject. Okay. So starting from equation 1, your x over 2 equals to 1 minus y over 3. So my x is 2 minus 2 over 3y. Now, it's up to you. Some people prefer to combine it, as in you write this as 6 minus 2y over 3. Some people prefer to leave it in fraction form, up to you. Maybe I combine it. Combining it perhaps will be a little bit easier, okay? So we're going to take this equation 3 and sub inside equation 2. My x is now 6 minus 2y over 3, and I square it, all right? And then you minus your y plus y squared, the result is 12. So when I expand this, please expand top and bottom separately. 6 squared is 36. 2 times 6 is 12. 12 times 2, 24y. 2y, if I square it, is positive 4y squared. However, the 3, I square it, I get 9. Yeah, I have a 9 here. Minus y plus y squared equals to 12. Now, this fraction is a bit annoying. So what we can do is multiplying everybody by 9, get rid of the fraction. So this will give us 9y squared, 12 times 9, 108. Okay, number is a bit big, but it's okay. We can now add them up. 4 plus 9, 13. 13y squared. Maybe I highlight for you so you know which one. These two I add up. Okay, and then minus 9 minus 24. Minus 33, right? And then 36. I bring this 36, I bring 108 over 36 minus 108 is 72. Okay, this is not a nice number, I would say, but it's not, we can actually solve it, no problem. We know we cannot factorize it because the question say, give an answer correct to 3 significant. We know whenever they say 3 significant, 3 decimal, we know we can't factorize it. We have to use quadratic formula. Okay, before you use quadratic formula, remember the formula is given by, let me write here, minus b plus minus square root b squared minus 4ac over 2a. This formula is given. It can at least refer to the formula list. Right, my b is negative 33 plus minus square root negative 33 square 4. A is 13, c is 72, divide by 2a. Okay, let's write down your y value. Let's count. 33 square, negative 33 square is still the same, positive 33. You want can put a bracket negative, doesn't matter. Minus 4 times 13 times negative 72. So this will give us 4833. All right. So 33 plus minus square root 4833. 2 times 13 is 26. Okay, this part here, we'll use our calculator and count. Let's start with the positive negative value first. 4833 over 26. This is negative 1.40. They say three significant figure. So first answer negative 1.40. Right. Second answer, just change the negative here to positive. And this will give us 3.94. 3.94. Okay, so that's the first one. So the second one is you take this and you sub inside equation 3 because we need to find 2 sets of y and 2 sets of x value. Okay, my x is now 6 minus. For the first y value is negative 1.40. I put it in. The second y value is 3.94. Let me put it in and count. Okay, first one, let me just write it down here. This is 6 minus 1 is a plus of 1.4. Divide by 3. This answer is 2.47. Yeah, 2.4. Wait, I hope I didn't make any mistake. Okay, there is a 2 in front. Actually, I missed out. There's a 2 in front. So the first answer, please put a 2 in front. 2. Okay. 2.93. Okay, the second answer, I will take this and let me just change it to 3.94. This one is actually a minus. 2 times 3.94. But previously, because double negative, I just type in as positive. Okay, so this will give us negative 0.627. Okay, 627. All right. Okay, question number 4. The first part A I'm going to do it here is involving indices. So we need to simplify this. We can see a 3 power negative n. You can write this as 1 over 3 power n, up to you. I think I'll leave it out first. But the 15 here, right? 15 here, I know we can change to 3 times 5. The whole thing to the power of n. Maybe I'll put another bracket, the square bracket here. 27 is 3 power 3. Yeah, there's an n here. Okay, step 2, let us break up this 3 times 5 power n to 3 power n times 5 power n. There's a minus 3n. So when you take this negative 3 power negative n and you times in 1 by 1, so what we have here is 3 power minus n plus n. When you multiply the number, we add the power. And there's a 5 power n. And this is 3 power minus n plus 3n. So we know this is going to give us 3 power 0. And anything power 0 is 1. And this is going to give us 3 power 2n. So, wait, 27. Yep. This one, you need to simplify this because we know anything power 0 is 1. And this is 5 power n minus, you can write 3 power 2n. You can write, you can even write 9 power n. Yeah. Okay. So we leave it like this because the question says simplify, right? So to what extent we can simplify, maybe up to here. We can't do anything more. We can subtract 5n with 3 power 2n. Okay. All right. So that's part A. So part B, they say express h in terms of a and b. Given that solution to this equation here is this. Okay. So this question a bit unique. A bit unique because Indices, Surds is actually something new in your new KSSM syllabus, and there's not many questions that you can find from the past year question. And this part here, normally we should solve for x, but this is the case. You're supposed to express one unknown in terms of another, right? So first of all, we know square root 4, right? We can actually change square root 4 to 2. So I'm going to continue here. 2 square root x minus 1 square root x equals to 3 over square root a minus square root b. So when you subtract 2 square root x minus 1 square root x is just square root x, right? And you have 3 over square root a minus square root b. Okay, and we're supposed to solve this and find and know that our answer is this form, just to compare h, right? So that we can find h in terms of a and b. I think it's easier, maybe we rationalize the denominator first. Okay, remember the idea of rationalizing the denominator is to simplify our denominator to a term without square root. So here we have square root a minus b. We have to multiply with is a conjugate. Conjugate is like twins, if you like. If it's a minus here, the conjugate is a plus. Everything else is the same. A reason being that when you multiply this with its conjugate, your denominator, we use the idea of a plus b, a minus b. When you take a plus b multiply a minus b, we get what we call the difference between the square. That means we get a squared minus b squared. The more we do that, for this case, your square root will disappear. Square root a times square root a is just a. Square root b times square root b is just b. Notice the square root disappear. So what we want to do is to is to get rid of the square root from the x. I want to find x, but this x here has a square root. Let me move out a bit. This x here has a square root. So I square the left and I square the right. So when you square the right, the left, the square root disappear. When I square the right, 3 squared becomes 9. This becomes square root a minus a plus square root b bracket square, and your denominator is a minus b bracket square. Now we know the solution is this. Can you see over here? This is your solution, right? I would copy this on the left hand side, square root a plus square root b square, and I compare with the right hand side. This is 9 a minus b square with the square root a plus square root b bracket square. You see, I purposely separate the denominator a minus b, push it outside. So I can now compare and say that this is equals to this. Because the rest are the same, right? This square root a plus b, square root a plus square root b bracket square, they're the same. So by comparison, I can say h is now 9 over a minus b square. Yeah? Okay? Quite an interesting question. All right. So one more thing about the new KSSM syllabus of Part C is that you would, in your textbook, can start finding questions involving exponential E. So not many questions on this you can find, right? We have an equation here, and then they say n equals to ln n plus 1, right? So we are supposed to find the value of n. So to solve this equation, we know we have to group all the e together. So maybe I bring the e over. Now this one, maybe I do a bit slower here. E power n minus 3. This one is 1 over e square. So I multiply this up. So this is e n minus 3 times e power 2. This is 1 over 5. Now in exponential, it's the same as solving indices. When you multiply the number, we add the power. So this is e power n minus 3 plus 2, which is minus 1, 1 over 5. Then we change from exponential form to index form. Now we know in normal exponential form, like in the indices, a power x goes to y, we can change x to logarithm form by writing log base a y. But specifically for e, exponential, e power x, if it's y, we say x is ln y. Ln simply means log base e, natural logarithm. So here we say n minus 1 is ln 1 over 5. And we are given that n is ln m plus 1. And we are supposed to find the value of m. So basically, just take the 1 here, bring it to the right-hand side. My n is ln 1 over 5 plus 1. By comparison, I know m is 1 over 5. Yep. Okay, number 5a, the first part is using progression to be exact, arithmetic progression. So here we have diagram shows Pak Abu and Pak Kasim's respective roti canai restaurant. Okay, Pak Abu started roti canai business by selling 100 pieces a day. Pak Kasim started by selling 400 pieces a day. Now then they say every day Pak Abu's restaurant increased the sales by 4, Pak Kasim increases by 2. So we can see here Pak Abu is a progression, right? Your A is 100, your D is 4. Yeah, it's an arithmetic progression. For Kasim, your A started off with 400, my D is 2. Okay, now they say that on the end day of the business, the number of roti canai sold by Pak Abu for the first time exceeded the sales of roti canai of Pak Kasim. So Tn of Pak Abu will be greater than Tn of Pak Kasim. Yeah, on the end day, we're finding what is the value of n, right? So we know we can use Tn in arithmetic. Tn equals A plus n minus 1d. Your A is 100. N minus 1d is 4. This is greater than 4. Pak Kasim is 400. N minus 1d is 2. Okay, now in the past, I would tend to expand all this, but nowadays I don't do that anymore because I think it's easier if you think this is 4 times of n minus 1. This is 2 times of n minus 1. So if I bring that over, 4 minus 2, you're left with 2n minus 1. Then this part here is 400. You minus 100, you get 300. As you divide by 2, you get 150. N is 151. If n is more than 151, remember n is an integer. Yeah, number of days more than 151, I must take 152. That means on the 152nd day in business, Pak Abu has sales more than Pak Kasim for the first time. Okay, yeah, so the figure. Okay, that is only part A. Let's look at part B. All right, diagram 5 shows Alia Christina plays a swing release from a specific position. Okay, so they say the distance for the first complete oscillation is 400 cm. Distance of next oscillation is 15% less than the previous one. So find the number of complete oscillation if the sum is less than 2434. Hence, determine the complete oscillation to what extent it produces a complete oscillation less than 40 cm. Okay, so I think the first thing is I need to start off by finding your A. My A is now 400, right? My common ratio R is now 15% less than before. So we say 100 minus 15 left with 85, right? So the 85 over 100, this is 0.85. Okay, so find a number if the sum is less than 2434. That means Sn is less than 2434. Now remember the formula goes like this: A 1 minus R power n 1 minus R. This is less than 2434. Okay, so let's just use our calculator. Okay, let's take 2434. We multiply by 1 minus 0.85, 0.15. Then you divide by 400. Let me do 1 by 1. This number you can change to decimal. Okay, you can leave it in fraction, up to you. So let me write 1 minus 0.85 power n less than 91275. 91275. Okay, let us bring this to the right, bring this to the left. 1 minus this, take 1 minus this answer, you will get 0.08725. 0.08725 less than 0.85 power n. Now from here, we have to introduce logarithm. Yeah, in fact, this is 0.85. Our n I write on the left. The other one I will write on the right. Introduce logarithm on both sides. Bring the power down, right? Divide them, right? Divide them. So remember, when you take logarithm of any number between 0 and 1, it's going to be negative. Like log 0.85, you notice, is negative. So how does this affect your inequality here? Well, whenever you times and divide negative, you just change the symbol. If you're unsure, just type it out in your calculator, right? I hope you know that. If n is a number between 0 and 1, LGN is always less than 0. If it's less than 0, when you divide, you got to change the symbol for your inequality, right? So, okay, let me type this out. Log 0.0875 divide by log 0.85. My answer is 14.99. So, 14.99. So, wait. I hope I didn't make any mistake here. This is log, wait, log 0.08725 divide by log 0.85. Yeah, 15. Wait, because I think I typed wrongly just now. It's 15, right? 15.007. Yeah, 15.007. Okay, if it's less than 15.007 and should be 15, we can't take we take the nearest integer. Yeah, we can't take 14 because less than 15.007, 15 is also a solution. Okay, there's one more part to this. Hence, determine the complete oscillation to what extent produces complete oscillation distance that first time is less than 40. So actually, you can't really use this result unless you want to use trial and error, as in you want to do P15, put inside your A is 400, then 0.85 power 15 minus 1 is 14. Okay, so this one is if you're using trial and error, 400 times 0.85 power 14. So what do you get? 41. So this is still not less than, yeah, 41.1, right? Or you can write 41.11. So we know this is not the first oscillation that is less than 41, less than 40. So we have to try with another one, T16. Now remember, it's going to get smaller and smaller as you oscillate. The length, the distance travel is reduces by 15% for each oscillation. So we do T15, 400, 0.85 power. This will be 15, okay? Or you can take whatever answer that we have here, multiply by 0.85, yeah? Just multiply one more time, you will get 34.94. 34.94. So answer is what? So what is the number of complete oscillation such as less than 40 cm? Answer is 16, yeah? 16, I'll just write n equals 16. You can write 16 oscillation. Okay, but this is actually by using a trial error because the question says hence. Hence, most of the time means you have to use the result, right? So, but if let's say you're not sure, right? And we can also use the Tn less than 40. Your Tn is now A 400, R 0.85. Remember, you need to do n minus 1, right? Less than 40. Yeah, formula for Tn. So take 40 divide by 400, that be 0.1. Then introduce logarithm on both sides. Bring the power n down. All right. And similar to just now, when you divide, when you take the logarithm of any number between 0 and 1, it's going to be negative. So your log 0.1, you divide by log 0.85 is going to be negative divided negative is going to be positive, but you got to change the symbol. N minus 1 is now more than 14.17. N is more than 15.17. Therefore, N is 16, right? So this part here, I don't use the result, right? I calculate all over again, right? Okay, question number 6. This is from the chapter Linear Law. So here we have 2 diagrams. The one on the left is obtained when you convert this equation to linear form, right? And you can see your big Y or capital Y represent the variable on the y-axis here, right? And this variable on x-axis, but variable on x-axis is not given. So we're supposed to convert this to linear form. Because you can see this is y over x power 3. What I have here is y over x. So by starting from here, I'm going to divide it by x squared so that I get y over x power 3. And mx squared, when you divide by x squared, you get m. This nx, if I divide by x squared, I get n over x. Yeah, so we got negative. Maybe I rewrite for you. This will be negative n 1 over x plus m. So this is your big Y. This is your gradient. This is your x. And this is your c. So what we want to do here is to show that n equals to 6m minus 18. Now the problem is in your first graph, we can see your y-intercept is h plus 3. My y-intercept from this graph here, this equation here is m. So we can say, comparing y-intercept, m equals h plus 3, right? Now you notice that your final answer, or maybe doesn't have h. So we know maybe we have to get rid of h later on. It's okay, I'm going to leave this out, call it equation 1. Then go back to the starting equation over again. This time, I want to convert to linear form by making my x-axis variable for the x-axis to be x. Yeah, to do so, you see there's a x squared here. I need to get rid of this x squared. So I'm going to start from there and divide by x. So y over x is now mx minus n. When you divide x squared with x, let's see, yeah, this is x squared, you divide by x, I'm left with x. X I divide x, I'm left with just 1, left with negative n actually. So I'm going to write here, this is your big Y, this is your m, this is your x, and this is your c. Okay, now again, we need to compare y-intercept. My y-intercept from the graph is minus 6n, 6h. My y-intercept from here is negative n. So we say negative n is minus 6h, and let us make h as a subject. H is n over 6, equation number 2. Now you may ask why we make h as a subject. Well, the final answer that we want to find, n in terms of m, there is no h. So by making h as a subject and substituting equation 2 inside equation 1, I can get rid of h, n over 6 plus 3. Now, let's multiply everybody by 6. 6m equals n plus 18. We're almost there. Just make n as a subject by bringing the 18 to the left, right? So n is 6m minus 18. Okay, next question, question number 7. So this is from the chapter Quadratic Geometry. Sorry, it's a bit blur. You can't really see clearly, right? So this is actually x over 2, all right, plus y over 4 equals negative 2. So this is the equation. Let me write here x over 2 plus y over negative 4 equals over 4 equals to negative 2. So this is the equation of straight line PBQ. All right. So point B lies on PQ such that 5PB is 2PQ. Yeah, 5PB. That means maybe I write here PB over PQ is 2 over 5. That means PB is 2, PQ is 5, BQ has to be 3. You're supposed to find the coordinate point B. Okay, so this is not difficult. We have to use the ratio, the divisor of line segment formula. That is xy equals to nx1 plus mx2 over m plus n. Then you repeat with your y. ny1 plus my2 m plus n. Okay, so here we have to first find out the coordinate point P and Q. Since you're given this straight line, we can change this to what we call the intercept form. Intercept form is written as this: x over a, y over b equals to 1. Okay, so what we can do is divide this equation by negative 2, because in order to change to this form, my right hand side has to be 1. Okay, we take 2 divide by this 2 here, we multiply with -2, I get x over -4. 4 multiply -2, I get -8. The result is 1. Therefore, the coordinate point P, yeah, coordinate of point P is -4, 0. Coordinate of point Q is 0, -8. Okay, remember, when we use this formula, the most important thing is that your n and your x, your ratio and your coordinate must be opposite. For example, if I treat this as m, this is your n, your 3, you need to multiply with -4. Your 2, you need to multiply with 0. Okay, so then write down the coordinate of point B will be 3 times -4 plus 2 times 0 divided by total ratio. My total ratio is 5. Then 3 times 0, 2 times -8, total ratio is 5 again. So let's put them together. This is -12 over 5 because times 2 times 0 is still 0. And this would be -16 over 5. There you go. The coordinate of point B is this. All right. Next one. Find the ratio of triangle A, area of triangle OPB to ratio of OQB. Okay, as you can see, OPB is this triangle. Maybe I highlight for you. OPB is this triangle. Okay, the red one. OQB is this triangle. The green one. Okay, now this question is, I would say a little bit silly because we don't need to calculate the area of triangle, right? Let me write here. You see, if I draw a triangle like this, okay, draw a triangle like this is your triangle, okay? We know this, okay, let me redraw nicely. It's actually this way. This is your O, this is your P, this is your B, okay? B may not be perpendicular, B may be here. This is B. This is Q. Now, we know area of triangle can be calculated by using half times base times height. For example, your triangle can look like this, right? This is your base, this is your height. Now, your triangle can also be an obtuse angle triangle like this, where this is your base and your height falls outside. So here we are finding the ratio of area triangle OPB, right? Which I've highlighted earlier. This one, the red one, yeah, this one, and OBQ, which is the green one, correct? Now, both of them actually share the same height, which is H. Let's call it H. So maybe I write here, let H be perpendicular distance. Okay, let me wrap this off. Perpendicular distance from O to line BBQ. So that's a H. If you want to find area of triangle OPB, divide by area of triangle OBQ, OPB we can calculate by using half times base times height. Your base will be PB, your height will be H. As for OBQ, your base will be BQ, your height will be H. Now notice we can cancel this, we can cancel half and half, we can cancel H and H. Now we are left with PB over BQ. Now we know the ratio of PB, BQ, right? This is 2 to 3, isn't it? So this is 2 over 3. Therefore, the area of OPB and area of OBQ is 2 is to 3. Do you really need to calculate the area using the shoestring method, half x1 by 1, x2 by 2, x3 by 3, repeat point number 1? Do you need to do that? No. We just take the ratio and divide them, right? Comparing the length of the base for each triangle, and then we get the answer, right? Okay, next one. This is from question number 8. This is from the chapter vector. Okay, so here we have a ball rolled from point M with a velocity vector of 4i minus 2j. So after t second leaving point M, the ball is at this position on equals om plus tv. So you're supposed to find the speed and the position of the ball from M after 4 seconds. Okay, find the speed and the position. Okay, well, actually, it moved at the constant speed, the velocity vector. Yeah. So what is speed? Speed is the magnitude of velocity. We know the velocity vector. The speed is the magnitude. Let's take 4 square plus minus 2 square, square root 16 plus 420, yes, square root 20. We can square root it, change to decimal, 4.47. 4.47 meter per second. Okay, now how do you find the position vector? Okay, so to find the position of the ball, we know ON equals to OM. The original position OM is given here, 512, right? T multiplied with the velocity. Velocity is 4 minus. So here I'm writing in column vector because it's easier compared to using ij, because ij is right, you could underline the I and j, so it's a bit troublesome. For me, I like to write in this form, 5 plus 4t, 12 minus 2t. Now, we want to find the position vector after 4 seconds. So we just put 4 inside. 4 times 4. And then this is 12 minus 2 times 4. 4 times 4 is 16. 16 plus 5 is 20, 21. 12 minus 8 is just 4. So your answer is 21, 4. That's position vector. Okay, next. When will the ball be at east of the origin? Okay, now, one thing to help you understand this, maybe I draw the diagram out like this. So we know the original position is at 512. 512 means here, 5 around here, 12. So this is your y-axis, this is your x-axis. Now, the ball is moving in this direction. 4i minus 2j means I go 4 units to the right, 2 units down. 1 second, I go here. 2 seconds, you go here. And so on, right? So at one point, as it moves in this direction, at one point, it will be intersecting the x-axis. So when it intersects the x-axis, it will be at the east side of the origin. East, I hope you have some sense of direction. North, south, north is up, south is down, east is to the right, west is to the left. So it would actually move here. This is your original position N, all right? At t second, the ball will be here, right? So it keep going on until at one point, it will cut the x-axis. So when that happens, we say your ON is a multiple of 1, 0. Why 1, 0? Because 1, 0 is I. Or we can say lambda I. The most important thing is that your J is 0. Your J component is 0 because it doesn't go up or down. It's exactly at the x-axis. So we know our ON here. I've already got my ON formula. Maybe I highlight for you this one. This is your ON, okay? Maybe I shouldn't highlight it. It's a bit hard to see. All right, so we're going to let this 5 plus 4t, 12 minus 2t, I'm going to let this be lambda 0. But like I said, the most important thing is not your lambda. What we want is your t. We want to let the j component, right, be 0. The vertical component, because when it's at east, right, it doesn't go up or down. It's exactly at the x-axis. Your y value is 0, the j component is 0. We can solve for t. My t is 6, right? So when will it be east side of the origin? At t equals to 6. That's all. Okay, question number 9. So this is from circular measure. This is one of the more confusing question. All right. So now, here diagram shows a water theme park. A company interested in buying and renovating the water theme park area intends to build 2 pools, a pool for adult and pool for children. So point B and H, the midpoint, B and H are midpoint. So these two are equal length. These two are equal length. Okay, so right, AG equals AC equals 2R. That means this is R, this is R, and this is also 2R. Okay, right. Okay, AG equals AC. So meaning if you join this together, can't see, let me just extend. This one is actually quarter of a circle because this is 2R. right? If I extend, it will actually D. If I extend the arc of a circle, you actually cut at G. Okay, so first of all, we are supposed to find angle BAH. So now you notice that they say H is a midpoint. This is 2R. So over here, this should be R, right? Isn't it? HF is also R. HB is also R. So if this is an R and R, maybe I redraw the triangle for you. It should look like this. This is your A, B, H. Your HB will be R. Your AB will be R. So this should be what we call an isosceles triangle, right? Now we already know this is 90 degrees. Yeah? So in this case, we say since AB equals BH equals to R, triangle ABC, ABH is 90 degree, or yeah, ABH is isosceles. Okay, isosceles is an isosceles right angle triangle. So therefore, this angle should be what? 45, 45, right? So maybe we can use BAH is 180 in radian is pi minus 90 pi over 2 divided by 2 pi over 4. Now, if you don't want to explain like this, we can also say tangent angle BAH is R over R. Angle BAH will be, use your calculator, shift tangent 1. Now, R divided by R is 1. So in degree is 45. Yeah, if you change your calculator to radian, or you take times pi over 180, you also get pi over 4. Yeah, same thing. Now, this for the first case, first one I use angle in radian straight away. This one I use degree, then I convert back to radian. Yeah, in fact, this calculator, you can just change your calculator to radian mode. Then inverse 1, you get pi over 4. All right, so this is the first part. Okay, second one. If the area of the adult pool is to be increased so that the area is twice the size of children's pool, without changing the length of AC, find the perimeter. Okay, so this part is the confusing part because they say area of the adult pool is increased. That means you don't change the children's pool, right? If you don't change the children's pool, basically we cannot change this triangle already. This triangle is fixed, right? I can't change the triangle because if I change the triangle here, then I'm changing the area of the children's pool. Now, the only way you can change the adult pool without changing the length of AC, without changing the length of AC, right, is to increase this angle to maybe like this, right? So that means that your adult pool will be something like this. The triangle stays there. The children pool has the same size as well. Okay, so maybe I can do one by one. Let's talk about area of the children's pool. Children, I put C. Yeah? We know previously this is R. That means this is R, right? Because AB is a midpoint. At the same time, HV is R, HF is R. This length is 2R. So it's basically a trapezium. Half sum of parallel side 2R plus R times height R. So this is 3R times R, 3 over 2 R squared, right? That is the area of children's pool. Okay, your adult pool in this case, we don't know what is the angle now, okay? Because we can't increase the size. You know, when we talk about area, right? Area is half R squared theta. Okay, you cannot increase the radius. You have to increase the angle, right? So we don't know what's the angle. We have to find the angle now. Okay, so we know half. Okay, maybe I use black pen here. The radius originally is 2R. So we put 2R square theta. But you got to minus a triangle here. Your adult pool, you have to subtract this triangle here. And the triangle doesn't change as well. So you put half R times R. Half times base times height since it's a right angle triangle. So this will be 2R. If I square it, becomes 4R squared. Divided by 2 is 2R squared theta minus half R squared. Now, it is given that area of the adult pool is 2 times the area of the children's pool. Your adult pool is 2R squared theta minus half R squared is now 2 times of 3 over 2 r squared. Our goal is to find the perimeter of the adult pool. So we have to cancel, maybe I cancel these two first. You're left with 3. Bring it over. Yeah, in fact, you don't have to cancel it because it's 6 plus 1. It's actually easier to count without canceling it. 6 over 2 plus 1 over 2 is 7 over 2 r squared. Cancel the r squared, divide them, right? 7 over 2 divided to 7 over 4. Theta is 7 over 4 radian. Okay, but we are still not done yet. 7 over 4 radian is about, let me see, 7 over 4 radian, 1.75 radian. So it's more than 90, less than 180. 180 is 3.142. So yeah, around here. So we're supposed to find the perimeter. Okay, your perimeter consists of, maybe I start from here. This is 2r, right? This is also r. This is also r. But I need to find HD and I need to find the length of this arc. Okay. For HD, right, we need to find the length of AC first. Okay. My length of AC will be, we use Pythagoras, r squared plus r squared square root, which is square root 2r squared sub 2r. Therefore, the length of H, let me continue here. The length of HD will be, the whole thing is 2. AD is 2r. So it's 2r minus sub 2r, right? Okay, now next, I need to add the length of this arc. Okay, length of arc H, let me just call length of arc HS. S equals r theta. Your radius is 2r, your theta is 7 over 4. This will be 7 over 2. 7 over 2, or you can write 3.5 r. So they're all in terms of r. And you're supposed to find perimeter of the new adult pool in terms of r. So let's add them up. First, we take 2r. The 2r is over here. Let me highlight for you. The 2r is over here. Then you add 1r, 1r, then plus HD. So plus 1r plus 1r plus HD. HD will be 2r minus 2r. Then you add one more. The last part is the length of this arc, the green one, the arc. So this is 3.5r. So I think the answer is not a nice number because you'll be in terms of surd and decimals. This will be 4, 2 plus 1 plus 1, 4 plus 2, 6. 6 plus 3.5 is 9.5. So this is 9.5 minus 2. Maybe I write 9.5 r minus 2r. We can put it together. Let me move this up a bit. We write this as 9.5 minus 2 bracket r. You can change the decimal if you want, but I think this is good enough. Okay, question number 10. The first part is from the chapter differentiation. Actually, both are from differentiation. The first part is the limit. Okay, so I hope you know how to find limit. So to simplify limit, before we substitute, we need to simplify this equation. Why? Because if you substitute directly, you get 3 squared minus 9, 3 minus 3, which is 9 minus 9, 0, 0 over 0. Now, 0 over 0 is actually undefined, so we cannot find the value. Yeah, it's not infinity, it's undefined. So we have to do something first. That is, we need to factorize top and bottom, x plus 3, x minus 3, divide x minus 3. Okay, so after you factorize this, you notice I can cancel these two. I'm left with x plus 3. And now I substitute x plus 3 inside. I get 3 plus 3, which gives us 6. Okay, that's the first part. All right. Second part. So diagram shows the measurement of a sole area of a shoe used by Mr. Kasim, the shoemaker. So the length is r, and then they give us that the sole area of the shoe is given by A equals to 4 over 9 r squared, right? So r is the measure of the length of the shoe in mm. So employee of Mr. Kasim have overcut by PMM. So that's your delta R actually. Yeah. Okay. From the supposed measurement of 225. Your R initially is 225. Now is longer. Yeah, your delta R is actually bigger. Your delta R is positive, so that means you actually increase the length by pmm. So express a percentage of small change in the area in terms of p. Okay, so I hope you know that when you're given a equals to 4 over 9r squared, this is the area of the sole respect to RR, in this case, is the length of the feet. So when we differentiate dA dr, this is 8 over 9r. Okay, now we know initial length is 225. So let's put 225 inside. 8 over 9, 225. Okay, so 8 over 9 times 225. This will give us 200, right? Okay, 200 simply means if today I were to draw or plot the graph of A versus R, right? So it's a curve, and the gradient of this curve at the point R equals to 225, the gradient is now 200. So that means for every 1 unit change in your R, the area will increase by 200. So now your R has increased by a small value. We call this delta R, and delta R is P. I want to find my delta A. So what is my increment in your area when your R increases by P? So we are using this approximation. That is, when delta R is small, delta A over delta R is approximately dAdr. Okay, we know our delta R. Your delta R is P. We know our dAdr. dAdr is 200. So your delta A is 200p. But we're not done yet, because this is just delta A. We are finding what? Percentage of change in the area of the sole. Now, when we talk about percentage of change, you must know what is the initial area, right? Initially, your R is 225. What is your area? We take 4 over 9 times 225 square. Okay, 4 over 9 multiplied by 225 square. That will give us a big number, 22500. 22500. So this is your initial area. So to find the percentage of change in your area, we must take your delta A, divide by your initial area. You can call it A1 if you like, initial area, multiply by 100. Your delta is 200p. Your initial area is 22500. You multiply by 100. Okay, let's find this. And your answer will be in terms of P. 200 divide 22500. And this is 2 over 225. You're going to multiply by 100. Your answer will be 8 over 9p. Yeah? Your answer will be in terms of P. Right. Okay, question 11. This is from trigonometry. This question is very interesting, right? Now here we have a tower, clock tower PTQ with a right angle triangle. All right, this is not right angle triangle here. So the angle of elevation of P from Q, R, and S are given as 3 theta, 2 theta, and theta. And you're supposed to express the height of the tower in terms of alpha, right? You notice this length is alpha, right? So here we have 3 triangles. I hope you can see the first triangle. We know they all share the same height. I don't know what's the height. Let's call the height H, right? So the first triangle, I will just highlight here. This might the yellow triangle here. Can you see? The ratio will be, we can use tangent. Tangent 3 theta is H over alpha, right? The second triangle, I'm going to focus on this here. You can see the green one. Your length of the base is now alpha plus 4. All right, or you can say 4 plus alpha. So tangent of 2 theta is now H over alpha plus 4. And for the third triangle, I'm going to use the blue one. This one, can you see? The blue one. Your length of your angle is theta. Your height is still H. But your base is now alpha plus 16. Yeah, 4 plus 12 is 16. So here we need to link these 3 together. Now from the double angle formula, we know tangent should I say, addition formula, tangent 3 theta, we can break it up into tangent 2 theta plus theta. So when you expand this, this is tangent 2 theta plus tangent theta divided by 1 minus tangent 2 theta tangent theta. Now we know a tangent, this is from tangent A plus minus B, right? Tangent A plus B is tangent A plus tangent B 1 minus tangent A tangent B. Okay, my tangent 3 theta we know is h over alpha. My tangent 2 theta is h over alpha plus 4. My tangent theta is h over alpha plus 16. You divide by 1 minus h over alpha plus 4 and h over alpha plus 16. So to simplify this, maybe I cross over first, right? I multiply over. This is h over alpha bracket 1 minus h squared over alpha plus 4 and alpha plus 16. This whole thing, we can crisscross out your h. I think we can take out the h and make our life easier. 1 over alpha plus 4 plus 1 over alpha plus 16. Okay, notice that we can actually cancel this h and this h. You're left with 1 over alpha. As for this, right, I will cross multiply first alpha plus 4, alpha plus 16 minus h squared, divide alpha plus 4, alpha plus 16. This whole thing is now equals to, let's cross multiply again, alpha plus 16, alpha plus 4, alpha plus 4, alpha plus 16. Good news is we can cancel off the denominator here, cancel this out, and let us expand this bracket. This is alpha squared plus 20 alpha plus 64 minus h squared. On the right, I got 2 alpha plus 20. Okay, let's multiply the alpha over. This is alpha squared plus 20 alpha plus 64 minus h squared. Let me move this up. And this is now 20 alpha squared plus 20, 2 alpha squared plus 20 alpha. Now, good news again, we can cancel this 2, right? Since I'm finding h, height of the tower, h, in terms of alpha, so, okay, maybe I do a bit slower. I bring this. Okay, let me write one more step for you. Alpha squared plus 64 minus h squared is 2 alpha squared. Bring the h squared over, bring 2 alpha squared over. Your h squared is now 64 minus alpha squared minus 2 alpha squared is negative alpha squared. Take the square root of it, right? My h is therefore square root of 64 minus alpha squared. Very long and interesting question. Yep. Okay, question number 12. So here we have, this is from permutation and combination. So we have 3 number cards, 4, 8, and 9. So you're finding a number of 3-digit number that can be formed using all 3 cards if there's no condition. Okay, when there's no condition, number of ways to arrange them is just 3 factorial, and 3 factorial is 6. Yeah, remember 3 different cards. There are 3 factorial ways to arrange them, or you can say 3, 2, 1. Okay, the second one, they say the even digit must not be side by side. Okay, notice you only have 1 odd and 2 even. So the even one cannot be side by side if you put the odd in the middle. So in this case, I need to put 9 in the middle. I'll put 9 here. So how many ways to put 9 in the middle? 1. The even 4 and 9 can be placed on the left or on the right. So how many ways to do that? 2 times 1, or we say 2 factorials. So the number of ways to arrange them is just 1 way to put the 9 in the middle and 2 factorial ways to arrange the other 2 on the side. Okay, not difficult, right? Okay, part B. So here, this diagram, we have diagram 12B shows a keychain to be hung on the hanger to be displayed to customer in the store. So we have all the letters here. We have nine of them. Okay, so find number ways 5 keychain can be hung in a row. So when you're putting in a row, it's very simple. Number of ways will be out of 9, I arrange any 5. So we say 9b5. Okay, use your calculator. Out of 9, I arrange any 5. That will be 15120. Yeah, 15120. Okay, so that is part B. Okay, part C. So here we have a hanger, diagram 12C. This is for hanging the keychain in 12B. It has a hook in the middle. All right. So find number ways 8 different keychain can be hung except on the hook in the middle. So we got 8 on the side. Yeah. 1 in the middle. And how many keychain do I have here? I have 9 here. Right. So that means I must get rid of one of them. Right. I can only choose 8 out of 9. All right. So now previously you can actually think this way. Out of 9, I choose 5. Then I arrange them. I hope you know that 9c5 times 5 factorial is actually 9p5, right? But here, we don't choose all because we only have 8 places to put a keychain. The middle one we can't put. So maybe I say out of 9, I choose any 8. After I've chosen 8, I need to arrange them. But here's the thing. This one is circular arrangement. Remember, circular arrangement, we have to minus 1. Yeah. Because if I put 1, 2, 3, 4, 5, 6, 7, 8, I can have 8 different positions to put them. They will have the same item on the left and on the right, right? So I don't need to explain further here. So we know that when you arrange in a circular arrangement, the number of ways now have to minus 1. Previously, if you take 9, I arrange 9. So yeah, or if out of 9, I choose 5, then I arrange 5. But now I'm taking out of 9, I'm choosing 8. If I arrange in a row, it'll be 8 factorial. But if I arrange in a circular arrangement, it'll be 8 minus 1, which is 7 factorial. Or you can say 8 factorial divided by 8. Yeah. Okay, so let's count. This is 9 choose 8 times 7 factorial. The answer is 45360. Yeah, 45360. Okay, now next, find the number of different ways all the keychain are hung together on the 9 hook if the vowel must be together. Now, here, how many vowels you have? You have O, you have E, you have I. So there are 3 vowels. Okay, but now I'm hanging all the keychain. In order for the vowels to be together, right, you got to think this way. The consonant must be in the middle. And you need to put the 3 vowel together. Maybe you got one more consonant here, 2, 3, 4, 5. 5 other consonant on the side, like this, and the 3 vowel together. So first of all, let's decide which one to choose first. Maybe I choose a consonant because I need to fix the middle part first. The middle one, the consonant, here we got 9 letters, right? 3 vowels, 6 consonant. So let's take the 6 consonant, we choose one. You can say arrange one or choose one, doesn't matter, because 6b1, 6c1 is also 6 ways, yeah, to put in the middle one. Then after that, I need to tie the 3 vowel together. Now, normally, before we do the circular arrangement, let's arrange in a row, like this, okay? So how many ways to put the 3 vowels together? Well, 3 factorial. Then, how many blocks do you have now? This is 1 block. Then you have 2, 3, 4, 5, 6. These are the 5 other consonants. So there are total 6 blocks. So how many ways to arrange a 6 block in a row? Well, that is 6 factorial. But because we are arranging in a circular arrangement, you either divide by 6 or you think 6 minus 1, which is 5 factorial. So in this case, 6p1 is 6, multiplied by 3 factorial, then multiply by 5 factorial. Okay, my answer is 4320. Yeah, 4320. Right. Okay, let's move on to question 13. This is from the chapter binomial distribution. Okay, probability distribution. Specifically, this is binomial. So here we have a test consists of 40 multiple choice question. Each question has 4 choices. Okay, Azura guesses the answer to every question, right? So estimate number of questions she guessed wrongly. Okay, so what is a probability that she guessed the answer wrongly? So in an objective, you have multiple choice question. You have 4 answers, A, B, C, D. Yeah? Yep. So in this case, the chances of her getting the wrong answer, there's only one correct answer, is the wrong answer. The chance of getting wrong answer, the probability of getting wrong answer is 3 over 4. Now your N is 40. So to estimate number of question, to estimate means to find the expected value, or we say mean, average. The formula is NP. So we take 40 times 3 over 4. Answer is just 30. Okay. All right. So the probability that excellent male students chosen is 0.25. 5 male students were selected from the group, all right, who sat for the test. So find the probability at least 2. Yeah, excellent students. So at least 2 is x greater equals to 2. So we take, we can't take 2, 3, 4, 5. I mean, we can, but it's a bit long, 2, 3, 4, 5. I think it's easier to use 1 minus 0 and 1. So here, if you use the formula, in binomial formula, remember px equals to x is given as ncx, p power x, q power n minus x. My n is 5. I choose none. P is 0.25, power 0. Q is 0.75, power 5. Then you minus 5, choose 1. 0.25 power 1, 0.75 power 4. Okay, just use our calculator. Now, by the way, you can type using a normal way, but you can also use this calculator if you have this Casio ClassWiz calculator. It's a really good calculator to calculate one shot. Okay, so we have 2 options here. You can press mode, press 7 for distribution, 4 for binomial PD. Yeah, we can choose, put a list. For example, list of variable means you take individual value. List means I find multiple value. For example, I want 0 and 1. So I put 0 and 1 here. I press equals. My n is 5. My probability is 0.25. Then there you go. They give us in this form. So we can just add them up. Just use your another calculator if you have another one, or you can write down that value first. 1 minus 0.2373. Then the second one you minus, move this down, 0.3955. So I got 0.3672. Yeah, 3672. Okay. Now ultimately you can use what we call the cumulative density. This is 7 again. You press, move this down, press 1 for binomial CD, cumulative density. You just press 2 for variable. So cumulative density, basically, they just add up to a value. So cumulative density of 1 means you're adding the probability of 0 and 1 together. So here I use 1. My n is still 5. Probability is still 0.25. I press equals. So what we're getting here is this sum over here. We're getting this sum over here. And this sum is 0.6328. So by taking 1 minus 0.6328, I will get this, the same answer, 3672. Okay. Right. Now, if you don't have the calculator, you can just type in 1 by 1, yeah, to get this answer. All right, next one. Part C. Busu answered 30 questions correctly and randomly chooses answer for the remaining 10. So he already answered 30 correctly. So that means he guesses the remaining 10. So in this case, it's a binomial, your n is 10. The probability of guessing the correct answer is P is 0.25 because you have the probability is still 1 over 4, yeah, of choosing the correct answer. So find the probability that she answered at least 34 questions correctly. In order to get 34 questions correctly, he must be able to guess at least 4 questions correctly. So this is very long. If I do list 1 by 1, 4, 5, 6, 7, 8, 9, this is very long. So what we can do is we do 1 minus 0, 1, 2, 3. Even then, this is a bit long as well. So you have to write down 1 by 1. In this case, it will be 10, choose 0. P is 0.25. Q is 0. This power 0, 0.75 power 10 minus 10 C1, 0.25 power 1, 0.75 power 9, minus 10C2, 0.25 power 2, 0.75 power 8, and then 10C3, 0.25 power 3, 0.75 power 7. Okay, for me, I would use this calculator. This is a shortcut to this. I press Shift Sum. Okay. You can use the other calculator, use the continuous, the cumulative density probability. You can do that as well because the calculator can add 0 to 3, right? Okay. Or you can use this calculator, for example, then choose alpha x multiply with p 0.25, 0.25 power alpha x, then you multiply with 0.75 power n minus x. Your n is 10 minus alpha x. Another function you can use. This is from, I want to find the sum from 4 to 10. So there you go, 2241. Yeah, 0.2241. Okay, just another option to calculate. Okay, question 14. The first part is combination, differentiation, and integration. So you're given y equals to this, so we can differentiate dy dx. The formula goes like this: v u prime. I'm using uv, u over v, the quotient rule. When we differentiate v u prime minus u v prime over v squared. Okay, your u prime will be 1 minus u v u prime minus u v prime over v squared. My v squared is 2x minus 3 squared. So let's expand this. This will be 2x minus 3 minus 2x over 2x minus 3 squared. When you cancel it, you get negative 3 over 2x minus 3 squared. Okay, so I've already shown that dy dx equals this. But to use the result and to show that, to find the integral of this, number one, we know that when you differentiate your y, you get your dy dx. When you integrate your dy dx, which is negative 3 over 2x minus 3 bracket square dx, you should get back your y, which is x over 2x minus 3 plus c. But notice what we want here doesn't have, what we want here, it doesn't have a minus 3 in front. So I'm going to divide by negative 3 on the left and on the right. So when you divide by negative 3, we write this as negative 1 over 3. Okay, there is a negative 1 over 3. And you have a 2x minus 3 bracket plus c. Now, whether you want to times, okay, sorry, there's an x on top as well. Whether you want to times in or not doesn't really matter. We can leave it like this. Okay, now let's look at part B. Diagram shows a pond, water, such that water volume is maximum. So here, the gradient function at point A is given by this. Now, gradient function is given by dAd. In this case, we should say dy dx. Okay, y is your depth of the pool, x is the width of the pool measured from the pole. So your dy dx is 2x minus 4. So in this case, you're finding equation of the curve for the base of the pool. That means you're finding y in terms of x. So let's integrate 2x minus 4 dx. This will be x squared minus 4x plus c. Now, since x is measured from the pole here, so this point will be 0, 0. So we know when x is 0, your y is 0, therefore your c is also 0. My equation representing the depth of the pool is this, y equals x squared minus 4x. Okay, now we're supposed to find the equation. We've done that. And then they say, Ahmad swam 3.5 meters from the pole. So find the vertical distance to the bottom of the pool at the time. So we know when you're at 3.5 meters, so which is around here, 3.5, maybe around here, we want to find what's your y value. So we just sub inside. Your y is 3.5 squared minus 4 times 3.5. Okay, use your calculator. 3.5 squared minus 4 times 3.5. Okay, so what we have here is negative 1.75. Okay, so, but depth, we have to take a positive value. So the vertical distance, the depth, if you like, is just 1.75 meter. Okay, then they say the curve on B is now moved 2 meters to the left. Find the new equation of the curve, and then find the volume generated in terms of pi with the area bounded by the curve. And x-axis is rotated 360 about the y-axis. Okay, so one thing to understand that initially the curve is like this. Okay, let me just sketch for you. The curve is like this. Y equals to x squared minus 4x. So when you move to the left by 2, you need to change your x value. Your x, if you move to the right, you minus. If you move to the left, you plus. So here I put a plus. You square it minus 4x plus 2. Let's expand the bracket. X squared plus 4x plus 4 minus 4x minus 8. Your y is therefore, this one is 4. 4 minus 8 is negative 4. X squared stays there. The 4x and 4x you can cancel. Your answer is x squared minus 4. Okay, so the new equation of curve is this now, right? You don't want to use this, it's also okay. We can just mentally work it out because we know here your axis of symmetry is at 2, this is at 4. When you shift to the left by 2, your axis of symmetry is now at 0 at the y-axis. So now we know they will intersect the x-axis here and here. But that is not important. The x-intercept is not important because we are going to rotate this 360 degree about the y-axis. So when you rotate 360 about the y-axis, we need to use pi x squared dy. Your lower limit is minus 4, your upper limit 0. So let's make x squared as a subject. X squared will be y plus 4. Bring over. So let's sub inside pi minus 4 to 0, y plus 4 dy. Okay, so when you integrate, it's up to you. You may want to integrate term by term. I like to use composite function. That is, I copy the bracket. This is power 1. I increase the power by 1, becomes 2. I divide by 2. I differentiate inside bracket 1. Lower limit minus 4. Upper limit 0. Now, take the pi over 2 out. Let's put 0 inside. So 0 plus 4 is going to be 4. And you minus, put negative 4 inside. Negative 4 plus 4 is going to be 0. 4 squared is 16. 16 times half. Answer is 8 pi unit cube. This is meter, so we can say it's meter cube. Right? Okay, question 15. This is the last one. Diagram 15a shows the graph velocity of an eagle at a height of k meter to catch a fish on the surface of the water. So the formula, the height function of the eagle is given by this. Find the value of k. Okay, k is your y-intercept. In this case, your ht. It happens when t0. T is the initial, the time, right? So we basically sub t equals 0 to find your k. So when you put t equals 0 inside, you get 1 over 8, 0 minus 16 square. Okay, let's take 16. 1 over 8, basically times 16 square. The negative, if you square it, is still positive. So this will give us 32. Yeah, your k value is 32. Okay, second part. Find the time in second for the eagle to catch a fish on the surface of the water. So we reach the surface of the water at when t is when your h height is 0. So we let our ht be 0. Okay, in this case, very simple. 1 over 18, t minus 16 square equals 0. You multiply the 8 over, it's still 0, right? Your t minus 16 is still 0. Your t is 16. Yeah? In fact, you don't have to write so many things. Yeah, just write t equals to 0. All right, next. The height in meter of the eagle 5 seconds after it catches the fish. So 5 seconds after that, we know this is 16. 5 seconds after that will be 16 plus 5, 21, right? Your t is now 21. 16 plus 5, 21. So we sub t equals 21. This is your Roman 3. Your height will be, let's put 21 minus 16 square. All right. So calculator again. This is 1 over 8. In fact, 21 minus 16 is 5, right? So because it's 5 seconds after that, so we can just put it like this, right? And my answer is 3.125. Yeah, 3.125 meter. Okay, we're not done yet. We still got one more, part B. So this is the figure shows a kingfisher bird catching fish in the water. So a kingfisher bird catches the fish in the same area. The height function is different now. It has the ability to catch a fish less than 1 meter from the water surface. Find the range of time for the kingfisher bird to catch the fish. Okay, so this one is a bit confusing because, well, you can say that the graph may go down like this, right? But we need to know the time, the range of the surface may be here, and we need to know what's the minimum, because they say that if your surface is at 0 here, yeah, at y or ht equals 0, it can actually go below that at -1, okay? But to confirm this, I think the best way to do it is to complete the square. So I'm going to take this ht, I'm going to complete the square. So when I complete the square, let's take half of -12. This is -6. You square it, then you minus 36. Then you add a 27. This is 1/10, t minus 6 square minus 9. Now, when you multiply inside, you get t minus 6 square minus 9/10. 9/10 is actually 0.9. So what we're saying is this, your ht has a minimum, the minimum height, the lowest it can go is -9/10 or -0.9 meter below the surface of the water. So actually that makes this 1 meter here, how do I say, is there is no point telling you it's less than 1 meter, right? Because the minimum height that it can go is 0.9. Okay, maybe if I draw like this is 0, this is -0.9. 1 meter is here, right? So it cannot actually go below 1 meter or even touches 1 meter. It can go up to 0.9. So the main thing is, in order for him to catch, for the kingfisher, the bird, to catch a fish, it must dip below your surface of the water. So we say your ht must be less than 0. So whatever working here, in this case, for me to double check to prove it, but you don't have to do that, right? We can just take 1/10 t squared minus 12t plus 27, make it less than 0. Okay, the 1/10 doesn't matter. When you multiply over, it's still 0. We can just factorize the rest. This is t minus 3, t minus 9. So in order to solve this quadratic inequality, you can see that your t value should be anything below the axis here. So since this is, remember, this is less than 0, we shade the region below. The time taken for it to catch a fish should be anywhere between 3 and 9. Right. All right, guys, that's the end for this video. Thank you for watching. I hope to see you in the next one. Bye.